Good afternoon, everyone, and welcome to section 5.1 and an example. In this section, we're looking at continuous random variables, and we're going to do the following example. This example involves the continuous uniform probability distribution. So our question is, in March in Pasadena, California, the temperature during the day is always between 70 degrees Fahrenheit and 80 degrees Fahrenheit. Of course, that's not in the metric system, but when I was living down there, all of our temperatures were in Fahrenheit, so I've gone with that, with an equal probability of any temperature within that range. Part A, what does the density curve look like? Well, we draw just a little tiny sketch. The lowest temperature is 70 degrees Fahrenheit, and the highest is 80 degrees Fahrenheit. And this is temperature. Or if you like, you could just write the numbers as 70 and 80 and then put the units down below in the legend. And remember, for density curves, we're not worried about what the y-axis is called. And we said that anywhere, everywhere, each of these values is equally likely. And so it'll just look like a box. If you want to be really strict about it, you would erase the sides and just have a line across the top, because otherwise it's not a function, but we're just not going to fuss about that sort of thing. So that's all I'm looking for that question. Let's look at part B, which is what is the average temperature? And we're not going to do anything fancy here. We're just going to say that by symmetry, because this is a beautifully symmetrical curve, you wouldn't describe it as unimodal just because it doesn't have that sort of mound shape that we're looking for. We said that the uniform distribution is just a different one. We don't really talk about peaks there. But by symmetry, our average temperature is going to be, wow, that's a terrible set of lines, but you kind of get the idea. Halfway, the mean temp. Is 75 degrees Fahrenheit. Now let's look at our final part, which is part C. What is the height of the rectangle and let's just go back to look at our picture. What we want is that the total area under the curve, which I'm highlighting here using my highlighter pen, we want that total area to equal 1. We can see that the length, it's just a rectangular box, and the length of that box is equal to 10 units. And so here's the height that we want. And by inspection, hopefully, you can see that the height is going to be 1/10. If you care about the units, it's 1 over degrees Fahrenheit. But the idea here is that we want the area. I'm just going to draw a little sketch down here. Here's our rectangle. The area is equal to 1. And we've got 10 units here. And so we must have. And remember that the area of a rectangle is length times width. Let's make that a script L. So in order to get the width, we take the area and divide by the length. And so we must have 1/10. Okay, that's about it.